about volcanoes on other planets and moons. A woman who has spent her career studying volcanoes here and throughout our solar system will be speaking tonight at UBC. It's presented by the Royal Astronomical Society of Canada. Dr. Rosalie Lopez joins us in studio. Thanks for coming in.
Oh, you're welcome. Pleasure to be here.
You're a Guinness World Record holder.
That's right. I have discovered 71 active volcanoes on Jupiter's moon Io, and that apparently makes me the discoverer of more volcanoes, active volcanoes, than anyone else.
Than anyone else in the world. Well, good for you. I didn't even realize there was such a category.
They made a special one that year.
You'll hold on to that, I'm
right.
sure. Well, that was your work with Jupiter. That took several years that you found those 71 volcanoes, and now you're working on Titan, which is one of Saturn's moons.
Right.
But before we just look at some pictures, tell me, why do you study volcanoes on other planets?
Well, volcanoes are very interesting, very fascinating, and when you study volcanoes on Earth, you're looking at a small set of what volcanoes can actually do, because, you know, there's only the gravity doesn't change and the composition doesn't change that much. When you look at volcanoes on other planets, you're looking at some very strange volcanoes, so you're learning much more about the process of volcanism and what makes volcanoes work.
And knowing how volcanoes work, or having a better knowledge of how volcanoes work here and on other planets, other moons, will help us to better prepare for volcanoes?
Yes, hopefully it will help us to understand volcanoes better, and eventually you understand how they work and what makes them erupt and when they're going to erupt. So that's the real aim.
Okay, now Jupiter's volcanoes, the volcanoes you discovered on Io, are quite similar to ours, correct?
They erupt molten rock. So in that sense, they're pretty similar to ours. Now, the volcanoes on Saturn, Saturn's moon Titan, and also another moon Enceladus, are very different because they are what we call cryovolcanoes.
Cryovolcanoes.
Yes, they're very cold volcanoes, and they erupt water, or a mixture of water with, we think, something like ammonia. So it's like erupting slushy ice.
Okay.
And what happens is that these moons have an ice crust, and underneath they have liquid water. And sometimes this liquid water can break up through fractures and erupt like a mixture of slushy ice.
Are there eruptions as, these are the ice volcanoes you're talking about,
yes.
Are the eruptions as powerful as what we see, or what we have seen with the molten volcanoes here on Earth?
Well, we have seen very few eruptions of cryovolcanoes, only on Enceladus, and they are more like geysers. Okay. They're coming out of particular fractures, but there are old cryovolcanoes on Titan, and we don't know much about the energy of those eruptions yet.
All right, let's take a look at some of these pictures. Now, this is part of the Cassini project, studying Saturn and Titan. What are we looking at here?
Yeah, well, we're looking at Titan, and you can see that it's covered by a haze layer. Titan has a very dense atmosphere. Is about 50% denser than the Earth. And so when we look at Saturn's moon Titan to see detail, we use radar. And some of the images we have coming up are radar.
Okay, what is this?
We have discovered lakes and seas of liquid methane close to the North Pole of Saturn. Of Titan. And this is what you're seeing as some of these lakes and seas of liquid methane. And this is a comparison with Lake Superior, so you can see that the lakes of Titan are really quite big.
Right.
Now, what happens, Titan is so cold that methane, which is a gas on Earth, can behave like water on Earth. So we have methane in a liquid state on Titan, and we have discovered these amazing lakes.
So that's what these are?
Yeah, using radar.
Methane lakes.
Yes.
They're all over the place.
That's right, and this is from another instrument, a spectrometer that can also see the surface. So Titan is a very, very weird moon, and you know, here we see some of the radar passes in which we are penetrating this haze and actually able to see the geology of the surface. And I'm studying the geology in general. The Huygens probe, this is an image from Huygens descending was a probe built by the European Space Agency, landed on Titan, and returned a lot of amazing pictures and amazing data. So we are piecing together this moon bit by bit, because before Cassini we knew nothing about Titan. It was completely covered in this haze, and the surface had never been seen before. So it's actually very exciting to look at a world which is really planet-size and see the real state for the first time.
So how long is this whole project going to take?
Well, we just finished our main mission that lasted 4 years. We got an extension for another 2 years, and we hope that if the spacecraft works well, if everything goes well, we're going to keep going for another few years.
That's always the challenge, isn't it?
Yeah, that's right.
Thanks very much, Dr. Lopez.
You are welcome.